I'm going to go through this page in the course manual. This is, again, still functions and models. That first portion, just these two examples. So sketch the graph of f of x equals negative x plus 1 times x minus 3 squared. So we're given the function f of x is equal to negative times x plus 1 times x minus 3 squared, and we're asked to graph this function. In order to graph this function, the first thing that we're going to find is our x-intercepts, so we can do that by setting x plus 1, whatever's in the parentheses are going to define what our zeros are because they have an x in it. So x plus 1 is equal to 0, minus 1, minus 1. X is equal to negative 1. So negative 1, 0. That's our first x-intercept. X minus 3 is equal to 0 plus 3 plus 3. Our other x-intercept is that x is equal to 3, and y is obviously going to be, not obviously, but it's going to be 0. So now we have our two x-intercepts, and we have to determine if they cross the graph or if they just touch and turn. So that is determined by the degree of each term. X plus 1 is, it doesn't have a degree, so it's just assumed to be 1, which is odd. 1 is odd, which tells me that we're going to be crossing the graph at this x-intercept. In this example, x minus 3 is to the power of 2, which is even. This tells me that at this point, I'm going to be crossing, or we're going to be touching and turning. Touching and turning. Okay, so now we have our x-intercepts. The second portion that we need to do, the second thing, so I'm going to try to write this so it's more visible. The second thing we need to do is find out the end behavior of our graph. And we do this by finding ax squared. And how do we find ax squared? Well, we just look at the highest degree of the variable in each term. When I say each term, I mean each parenthesis. So x is the highest degree variable in this term. So that's just going to be x. In this term, the highest degree is going to be x squared because we always distribute that out. So we have x times x squared, and don't forget that negative sign hanging out there. So our ax squared value is negative x, so again our rules, 1 times 2, power of power, is negative, no, we add these together. So 1 plus 2 is equal to negative x cubed. And what does that tell us? Well, the fact that it's odd tells us that we're going to be going in opposite directions. The fact that we're negative tells me that our graph is going to look something like this. So it's reflective about the y-axis. The regular version of this odd graph would look something like this. So as x approaches infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. That's the regular version, but since it's a negative sign here, we flip that. So this tells us our end behavior, which is going to be like this. Perfect, and our last portion is just finding our y-intercept, which we can do by plugging in 0 for x. So f of 0 is equal to negative 0 plus 1 times 0 minus 3 squared. So 0 minus 3 squared is just going to be negative 3 squared, which is just 9. So x is 0, y is 9. We plot this all on a graph. So we have our x-intercept at negative 1, 0, and at 3, 0. And then we have a y-intercept, which we just found, at 0, minus 3, negative 9, right? And then we know that here, negative 1, 0, there is odd multiplicity, which means that we're going to be crossing the graph. And our end behavior tells me that we are going up here I guess the best way to start is with the end behavior. So we're going up and then down. We can just connect it by knowing that we cross at this value. And this is our y-intercept, and we touch and turn at our second value, because again, we had even multiplicity here. 0 minus 3 squared. Oh, sorry, yeah, I was wondering why my y-intercept wasn't correct. So if you plug in the 0 at every instance of x, 0 plus 1 times 0 minus 3 squared, so you get 9 here, and then don't forget that negative, so it's going to be 0, negative 9, and that's our y-intercept. The main thing to understand about this when you're actually graphing it is start by doing your end behavior, which we figured out over here by finding the ax squared term. That way you know how you cross the graph and how you connect those points. All right. Second portion of that page is asking us to graph a piecewise function. So let's do that. Given, here, I'll make a new video for that.